This is the Slackware ARM podcast, and this is season 3, episode 2. I'm Stuart Winter. I developed the ARM platform support for Slackware, and we've had the 32-bit version of Slackware ARM for a long time. And just recently, the 64-bit port has been released, which is my lockdown project, basically. And Brent has been helping along with that for the last... How long is it now? Is it obviously at least 15 months, because I wrote that in the changelog, but...
Since the beginning of time.
It does kind of feel like that. You know, so last night I was just hacking on something for a few minutes. I just wanted to check one of the packages that it was building. Oh, I know why. Yeah. So I took a non-public release that Patrick had pushed out, and I didn't realize that it wasn't the public version of that batch. It was a pre-release version, and I didn't realize. So I set my build system going, and then it tripped over the ICU upgrade. Mm-hmm. And I couldn't really understand why. It was complaining about not trying to link to an older version of it, and I was like, what? It didn't make any sense. So I spent a while looking at it and I couldn't figure it out. And I realized it's because I've got a mixture of different packages and they weren't linking together properly. So I had to refresh it and start it off again. I had to look at the man page again for readelf to have a look at it to remind myself of how to use it and what the output meant. But that was fun. So yeah, Brent's been helping along with the project, haven't you now for what it feels like at least 2 years, but a bit more bit beyond that as well, I think.
Yeah, I mean, I started doing other things and just kind of fell into this with you. So
yeah, it's been a good time working on this. I think most in part as well. I was thinking about this as I was cutting the grass again this evening, because it's quite a nice day and I need the grass cut. So as I cut the grass, these ideas come in, and and I was thinking that actually the Slackware ARM project is now better than it used to be, simply because I was working with you. Because if it was just on my own, I would have made it how I wanted it or how I needed it in order to support those hardware models. But because I was working with you and you're already working on other, the Raspberry Pi support ahead of me, you were saying that certain things weren't working. So I just made certain features so that you could actually try stuff out while I was busy doing something else. And at the same time, you just gave me the files and I just stuck them in the source tree. And then that was pretty much it, wasn't it?
Yeah, I mean, to be fair, mostly it was just figuring out how to write the SD card and get U-boot to boot the Raspberry Pi stuff.
Fundamentally it is. But the key thing about it is that it's about how you go about integrating it. How do you go about implementing what your research is? How do you go about standing up the system in a scalable way? So in the sense of how do you, because I don't know if I guess it's pretty clear to you because you've been working on it, and it hopefully will be clear when I write or finish writing the direct integration docs. It's just how easy it is to integrate Slackware into, or rather I should say, onboard another hardware model, such as anything really, any one of the other ones that are on the market. How do you integrate support for that into Slackware? And really, it's a case of editing some, or copying some existing reference scripts and just updating them for your hardware model, pretty much, as long as the support is in the upstream kernel, anyhow.
Yeah, I mean, and I had another board I was trying to get going, and if it just doesn't have the hardware support, it's just not going to work. But yeah, Raspberry Pi has great support, so.
Yeah, it does now. Yeah, it does now, actually. So yeah, let's talk about that. So did the release now was what? I don't know, almost 2 weeks ago, maybe a week and a half. I don't remember.
Yeah,
something like that. And it's really good that the response on the forum has been really positive. So I was really pleased about that, because it has been a lot of work. It's been taking quite a long time to get it out. And really, yeah, pretty much the only thing that's not great is the video support on the Raspberry Pi 4 and 3. So that, which is known anyway, already, that was called out. So I'd expected that. But yeah, other than that, yeah, it's really good. I'm quite pleased with the positive feedback on that. You never really know what people are going to make of it, do you?
Yeah, I was kind of worried people are going to be like, this is garbage.
Well, it's definitely not that. No, it's no, I'm really pleased with it. I think, I was thinking as well about what we could do. I'm not sure if people are actually interested or how interested people are in how the distribution works. I don't know whether, for example, if we talked through how to, how to integrate things. How does it work? Are people actually interested in listening to that, or even just talking through perhaps walking through some of the changes that are made, so you can understand how the system is brought up and what the component pieces are and how do you control them and that kind of thing. I don't know.
Yeah.
I mean, I'm interested in that. I don't know if anyone. I could just do it anyway. We could just talk about it, Brent. But
Yeah, we did talk about some of it before when it was being designed, but
yeah,
it's more baked now, so.
yeah, exactly. Muttley is now running the latest kernel. Which one is it? Yeah, 5.17.3. Well, the latest at the time of recording this video. I backed out that patch that I showed you in the previous podcast episode, and which was fixing this error to do with the I think the clock speed on the for the VC4.
Yeah, the video driver.
Yeah, so I was just trying to struggle to think what it was now because I backed it out and then kind of forgot what it really did. Yeah, so I backed that patch out, and I've also upgraded the. So I'll show you. Let's do a bit of a show and tell. So in Slackware ARM, there's a package called HWM-BW-Raspberry Pi, and it's in the A series here. So I'm just going to show you though. Yeah, and this is the initial bootloader firmware for the Raspberry Pi, or bootware as I call it. And so this is all the stuff that is in boot platform in here, which is the FAT partition for the Raspberry Pi on which its native bootloader lives. So this package here, HWMBW Raspberry Pi, this is a Slackware package that contains the latest version of, well, actually, that's not necessarily true. It doesn't necessarily contain the latest version. It contains the version that seems to work with Slackware.
Yeah.
Well, I suppose you should say
The one that lines up better with the kernel version we have, basically.
that. Yes, exactly. Thanks. That's better put. So, or tested is another word.
Yeah.
And works. So that's a better way of describing it. Basically, so this package manages all of this firmware here. And in other distributions, there's a script or a tool or something called RPI-update, and which would manage this for you. But in Slackware, it's all managed inside of this package here. And so I've taken the latest. So on the bug report, I was doing a little bit more research for the VC4 stuff, and there were some recent comments about how somebody'd simply updated to the latest version of the Raspberry Pi firmware, and it worked for them. And so I did the same thing because we were a few versions behind. Ours was, I think, only maybe 3 or 4 weeks behind, I think. But I've updated it and backed that patch out, and now you'll see this looks a lot better than it did before.
Yes, way better.
So, however, it doesn't mean that the video is fast. Although, no, yeah, I was just thinking, I've already tested it before, but what I've done is this machine's a fresh installation from this evening, actually. So for the Raspberry Pi native bootloader config, I've really slimmed it down because there was a lot of stuff in there to do with I planned to support having the Raspberry Pi native bootloader boot Linux directly rather than chain load U-boot, which is what we're doing at the moment. But then once we got well, thanks to Jeff on Linux Questions for doing the research on this one, research and testing. Basically, as you saw in the previous podcast episode, there was basically a problem with the Raspberry Pi 4s, the newer versions, and Linux couldn't see the micro SD card. And it turns out that actually the easiest fix for this is simply to have the Raspberry Pi native bootloader handle all of the flattened device tree and the device tree overlays itself, rather than using U-boot, which is what we were using before. And all you had to do is simply disable or delete the configuration option in our U-boot config to prevent U-boot from doing it. So that was the easiest solution. And it means now that I'm not concerned in the slightest about handling device tree overlays, because now we're going to use the standard that everybody uses on Raspberry Pis, which is to use the Raspberry Pi native bootloader config file, because then you've got a whole plethora of documentation out on the web that you can use easily to configure DTOs. So yeah, that's a real win actually. And then I thought also there's no point in booting Linux, is there, from the Raspberry Pi native bootloader when you can use U-boot? It's not like it doesn't achieve anything booting it natively. So I thought, why even bother looking into it? So I deleted all of the experimental notes from the config and just cleaned it all up. So here we are. This is the settings for the Raspberry Pi 4. And as you can see, we're still shipping these with these commented out. So if you want to experiment with this, then you'll need to uncomment these and save it and reboot. I'm going to leave this for the moment, but Brent, you were talking about a module called V3D, weren't you, that we need to add in?
Yeah.
Okay.
Well, what I've done is I changed the DT overlay setting to point to, I don't even know what your config looks like. Let's see, because we have different config files now.
Yeah, this is going to be the default one.
Yeah, you see the one that says V3D-Pi4 at the very end of it? That's the one I've uncommented.
Oh.
And then the rest was...
What about this stuff?
I didn't touch any of that.
Oh.
The memory was left commented too.
Okay.
And I uncommented max frame buffers and HDMI 4K. Yeah.
Okay.
But I mean, it seems to be in XFCE, it's running fine with the video, but I'm running it from a video player on my desktop. I'm not running it through Firefox.
Okay.
So,
well, hang on, I can test this then. So if you, oh yeah, I did on the memory. I read that you should generally leave it unset and let it handle it itself.
Yeah, it does.
You shouldn't need to do that. Okay, so if I save that, do I need to have the mod? Well, actually, I can do that when I reboot it, can't I?
Well, if you don't have a 4K monitor, the HDMI part won't matter, but that's just what I have.
I don't think it is.
Yeah. But if you have a video, you can just try it out, see if it does any screen tearing. Yeah, mine gets stuck at the hardware virtualization thing.
Because yeah, somebody else on the forum said that, but I've not had that before. It usually just reboots.
Yeah, mine too. So it's something with the latest kernel we have, I think. It'll probably be fixed by itself eventually by upstream.
Well, I mean, the installer was using the same kernel and it rebooted. I didn't have to do anything. So I think it probably gets itself into a weird state, perhaps, rather than it can't be missing any support or anything like that, because otherwise it wouldn't reboot most of the time. We wouldn't have rebooted in the installer. So I guess something's gone wrong somewhere. I don't know. That's kind of my as deeply technical as I'm going to get on that one right now. I have encountered issues in the past where on the Banana Pi, some of the power support had been moved into a different module, and I had to go and add some extra modules in order to get it to reboot. I don't know much about that stuff.
No.
Let's see. Okay.
So I'm interested to see what happens now that you have working GPU.
Let's just see what the.
I don't see anything about V3D though.
Oh, I didn't load the module for it.
Oh yeah, that's right. Okay, so on boot local, I just added that and then ran the RAM disk generator. I put it in the load kernel modules post,
Okay.
and it's just mod probe v3d.
Okay, so this file here that I've just edited is it's in boot/local. This is a Slackware ARM edition, so you won't find this in x86. But this is the Slackware ARM port has a different way of different structure to the operating system initial RAM disk, and it's managed differently because we ship a generic initial RAM disk rather than on Slackware x86. The tools create a specific RAM disk for the hardware on which it's being run, whereas we provide you a generic initial RAM disk that runs on everything that we support, because you have to do that, and you can do that in the ARM world. So we've got different ways of you guys being able to control how that works, control the functionality and the configuration. And this is one of the tools to do that. And in this is simply a shell script. So we just need to put in here. Ooh, screen doesn't. It's because of the. Oh, hang on a minute. Sorry, being silly. Cool. So. There we go. Let's try it again. So this is the reason that wasn't working is some weird serial setting I've got. I was previously accessing that over the serial ports.
Oh.
That's because I've just done the installation on it and stuff. So let's use an SSH connection here. Right, because the settings work. So yeah, this script is, well, actually, I'm not going to tell everything about what can be done in here because it's pretty well commented. But you can even, within this script, you can set up functions using bash that then get executed during or well, within the operating system initial RAM disk. So you can actually set up bash functions here to control things in the early stages of boot, which I think is quite a nice extension there. What did you say the module was called?
V3D.
Okay. Right, so then what we need to do, so, oh, I didn't rename it, did I? There we go, I need to rename it back to the, I need to name it to what the, what it needs to be. Oh yeah, so there's a README file in here that's quite useful as well. So this explains everything in this directory. And you can just find all the help you need inside of that. Okay, so I've created that file there. And then I'm going to execute the OS initRD manager, which will incorporate these local changes, these local customizations into the initial RAM disk, so that when it next boots, those changes will become effective.
I see that your firmware is already up to date. Firmware is in sync.
Yeah. Yeah, because of the because the firmware cache, or rather the firmware gets synced in the installer. Well, at least I told it to sync it in the installer. Yeah, that's good. Oh yes. So one of the things I did today was the OS initRD manager. It couldn't. Well, when you upgraded the kernel modules package before the kernel package, the modules in /lib/modules get the old versions get removed by the package tools and replaced with new versions, as it should. The problem is with that is that the OS initRD manager uses modinfo to determine what firmware is available for the loaded modules. and when the modules go missing, then it can't work. So it can't determine which firmware to add into the initial RAM disk. So I've made it now use the cache from the previous run and do it that way, because it can't discover it's not going to be able to discover firmware for itself using mod info until you reboot into the new kernel. So yeah, I spent I haven't tested it yet, but I've written the code and I think it works. It looks like it'll work. It's quite funny actually. You were saying earlier about how it's easier to. You wish it was as easy to create things as it is to break things.
Oh yeah.
And I was thinking, when I looked at the code, because I'd written it, I added this firmware stuff after I'd written the OS initrd manager. I hadn't originally planned to add to make it do firmware, but it was easy enough to add it. And as I was adding it, I realized that this situation would occur when the modules were missing. And I thought, oh, well, maybe it won't be a problem then. So I just made a note of it. But then when I came to implement the support for it, I suddenly thought, oh, how much code am I going to have to change to make this work? So I was kind of trying to figure out what was the path of least resistance. Because, if you don't design something, you don't expect necessarily to have it to support something else in the future. So it's kind of like, to what extent do you make your code scalable without going to over-engineering it versus.
Yeah.
So I managed to fit it in quite nicely, actually. So that was, I spent about an hour looking at it, thinking, yeah, I can do some, yeah, and then just coded it. It seems to work. But I'm going to test that and have that in the next kernel. Let's reboot. In the next kernel release. Let's see how this reboots this time. So yeah, I'll put that. I'll test the new version of the OS initrd and hopefully have that in the next kernel release. So I guess 5.17.4 or something. Okay, you're going to reboot. Yeah, look. So it's already got the exiting hardware. There we go. Yeah, so it rebooted this time.
Mm-hmm.
Okay.
That's what I was wondering, because mine was getting stuck on a reboot, and then I ran the RAM disk generator. I haven't rebooted yet though, so that'd be interesting to see if it fixes that. I don't know if that has anything to do with it, but
you shouldn't do, because I don't think that you need the firmware. So the OS initrd manager will take all the firmware that that the loaded modules expects to be able to load or can load. So it will take all of those firmware files and incorporate them into the operating system initial RAM disk indiscriminately, because there's not. I say indiscriminately because I thought perhaps it would end up copying megabytes and megabytes of firmware, but I tested it on a few systems and it doesn't. It's pretty minimal actually. So you don't need all of the firmware that ever is going to be loaded on your hardware model or your device. You don't need it all to be in the operating system initial RAM disk. You only need certain things like for the display drivers and stuff like that. But yeah, the operating system initial RAM disk manager indiscriminately puts all of it in there, because there's no way of knowing what you need and what you don't without manually figuring it out. But what you're going to be able to do, if I was thinking about this earlier, when the people who've already got it already got Slackware AArch64 installed, when you come to upgrade the kernel package, I think you'll have to run you'll have to boot into the new kernel and then run OS initrd manager once and then perhaps reboot again, because otherwise I don't think you'll ever get a cache otherwise from OS initrd manager. I was thinking this through earlier about how I would handle that, and I thought I'll just tell people just to run it once. Anyway.
Yeah.
But then I also thought it doesn't really matter, because you don't really need all this firmware in the OS initrd manager anyway. Some of it's useful to have, but you don't really need all of the stuff that's in there. At some point, I might need to get go on a bit of a cleanup with it, but I don't think so. Sometimes it's just easier to take the path of least resistance, particularly when it doesn't really make a big difference. Like it doesn't, you know.
Yeah, well, once it's ran once, it doesn't
Yeah.
matter anymore, really. So.
No, exactly. No, it doesn't. It doesn't matter. It's more just whether the OS init RD gets too large, just increases in size. But I don't think that's a problem actually. If it is, I'll deal with it. So I've got that module loaded, and that module, the V3D module, we added into the OS init RD. I will add that. I'll show you guys adding that in actually. I'll add it in a minute, and then on the next build, it'll be in there. Okay, Sean.
From what I can see, it looks like that module that we loaded handles a GPU scheduling. So,
Okay.
but that I haven't really read through all the docs yet, so I don't really know. I just kind of wanted to try it. I was like, okay, I'll just try that, and it seems to have some good effects. So,
ooh, this to me looks faster. I'm using KDE on the Raspberry Pi 4. It does seem a little bit faster than it was.
try launching a video and then dragging it around the screen. No more tearing.
Well, I'm moving Firefox around quite rapidly, and I can.
Yeah.
I mean, it's not bad though. Actually, it's better than it was. Ooh.
Before I was getting like trailing screens when I dragged the window around.
Okay. You know what I'm going to do, Brent? Actually, I think because this is definitely an improvement. I wonder whether I should, unless it hangs. That's the other thing, though. When the last time we were playing around with this stuff, it was okay for about 10 minutes, and then the whole session hung. It was unrecoverable.
I have HTOP running, and it's using only half the processing power, whereas before it was using 90% on all cores.
Okay.
So it's definitely doing something. I don't know. We'll have to go through the whole thing of leaving it running for days and see if it crashes.
Well, actually, I'm just thinking if this works, which it. Yeah, I tell you what I'll do. I was going to push out the updates quite soon. I've still got, I think, Firefox building at the moment. Has it got KDE in there? Has it? Okay. Yeah. Okay. So now it's building KDE. So what I'll do is I will. Let's have a look. Where is it? Here. Oh, yeah, there we go. So would I need this for this module need to be loaded on the Raspberry Pi 3 and 4?
No, this is only for the Pi 4, as far as I know. That's what it said on the documentation.
Okay, so it's 2711 then.
Yeah, right after simple DRM.
Okay.
B3D.
B3D. Okay. So what I'm doing here now, this is not a user serviceable script, by the way, but I'm showing it on the podcast because maintainer, that could be me, I suppose. Let's go with that. Oh no, I know why, because I thought that you might maintain it as well. But tell you what, I'm going to put me down. There we go. It's a mixture of both works there. Yeah. So what this file is a plugin to the Linux kernel module loader for Slackware ARM. And its purpose is simply to define, well, it defines what kernel modules specifically, in this case, the Raspberry Pi 4 requires. And this list is loaded in with a sort of base list. So there's a base list of kernel modules for all platforms, all hardware models. And then the kernel module loader loads in each of these different scripts, which are in this directory here. So we've got the Raspberry Pi 4, Raspberry Pi 3, and then the Rock Pro 64 and Pinebook Pro and whatever else is based on that. So it loads these different scripts, and then these scripts detect which hardware model they're running on and make some finer distinctions, set some additional modules. So in our case, what we've just done is I've added in this module here, v3d, into the video string. And this is simply just bash shell script, right? There's nothing complicated in here at all, which is also harks back to what I was saying earlier about, it's, I was looking at this the other day and I was really surprised how you can make an OS boot and do all of this, all of the, essentially what is complicated stuff in a really straightforward scripting language. I love Unix shell. I think it's like the best of both worlds. I mean, it's not fast, it's not a programming language, but the extent to which you can control the system due to the way that the Unix tool set works, the way it's the tools are expected to be called, you can put in, you can put them through pipes and stuff like that. You can do so much, you can build such complex things or control such complex things with a really simple scripting language with the access to the environment tools. I love it. Anyway, what I've done is I've just added this module in here to this script. And when I rebuild the kernel, which I'll do in a minute actually, this module will be included in it. So the new generic initial RAM disk will have this change in it, so that when you get the new kernel, the module will be loaded, and hopefully your system too will get faster on the video. The only other thing I need to do is I think, hang on. Yeah, platform. Oh, let's do that on the other machine actually.
You can probably remove the postscript in bootlocal too, since it's in there.
Oh, that's fine. Oh yes, yeah. So that script that I added in the this /boot/local, that's just on that particular machine's file system. That's not part of the Slackware distribution. So the OS initrd manager tool has recreated the OS initrd on that particular machine with that customization. So those are local customizations. That's how you can go and make these things work. If you're onboarding Slackware onto other hardware models, you can use that type of functionality to test things, to add it in. And then in the case of Brent, he said, oh, we need this module. So then I'm going to go and add it into the version inside of the initial, the generic initial RAM disk. So that's one of the ways Brent's identified. Here's a module. I've tested it doing this, and it's an easy way for him to test. You just stick it in that sample config file. Let me know, and then I'll bake it into the upstream, into the Slackware ARM upstream. What am I doing? Oh yes, so. Don't do that at home, folks. Oh, hang on. Oh, okay, no wonder it didn't work.
Oh, God. Just remove it.
So what I need to do is, so this is the config I've just tested. So what I'm going to do then is, tell you what, shall I take this out then? Yeah, I'm going to take this out.
Yeah, try it without that stuff. Yeah, it should load what it needs.
No, I'm just thinking, because this is the one I'm just testing on the desk right now. If I don't, oh, hold on. That's okay. I know what I'm going to do.
It's kind of funny. I unchecked use recommended performance settings in Firefox, and the processor uses way less juice to use Firefox. It's funny.
Does it?
Yeah, it just leaves the option use hardware acceleration when available, but I don't have that, so it just doesn't try and use it.
Okay.
Kind of videos are working now in Firefox.
So I'm inside the source tree from which the Slackware installers are created, which that partition on the micro SD card that gets converted into your /boot in the OS. So I'm inside the source tree for that, and I'm just going to change the default Raspberry Pi 4 config. I was going to copy it off the Raspberry Pi 4, and then I realized that actually I'd already changed it earlier on in the day. So I think let's take this out. I'm just going to leave that in for the time being. So this was the one you said to uncomment, right? The Pi 4
Yeah,
one.
I would leave that one, but I don't know about the other ones. It's up to you.
Well,
I don't know what they do. I haven't been paying attention to those.
Okay. The max frame buffer stuff, I'd read that made it work. That's why it's in here in the first place. I read that was successful. So I might leave that. I mean, yeah, I'm going to leave it in because it's working on mine. And I did read that it was good. I mean, obviously, I'd have to, in order to do this, I'd have to go and comment these out and just retest it over and over. But I'm not going to do that at the moment. And this was the other one, wasn't it, that you uncommented? The
Yes.
enable one. Okay, because it's working on mine anyway.
Yeah.
Okay, cool. This was the other one here, the disable FW KMS setup. I think it was supposed to be used, but it doesn't seem to be needed. So I think I'll, oops. Yeah, so I think I'll ship that like that. So I'll rebuild the kernel as well to include that v3d module, and then we'll get this as the default. And then for people who want to go with this new default, they'll have to wget or whatever. They'll have to download this off of the FTP site and bung it in their /boot/platform directory, and then reboot after they've upgraded to the new kernel. Because I've not got because the Slackware management or the packages don't manage these config files. I deliberately didn't want them to. I don't think it's wise to start messing around with people's boot configs once they've been lovingly
They configured something that uses an overlay and all of a sudden doesn't work.
That was actually the moment when that happened to me. I was using Red Hat. That's what I was. I'd learned Linux on Red Hat 3 or something like that, and it used Linux Conf. And I'd spent hours making this beautiful bind configuration for all my zones. And I ran Linux Conf, and it rewrote everything. And and there was no backup. I didn't expect it to do that. And that was the moment I actually stopped using it and moved on to Slackware. So I don't want anyone else to have that kind of experience, at least not generated by me anyway.
Yeah. Yeah.
Those are bad times when that kind of thing happened, I tell you.
Or Slack package new config and you override everything.
Yeah. Right. How's this thing doing? Okay, so KDE is building. Yeah, cool. So is that still doing anything? It is, yeah. So this machine's currently running a system integration test. So actually, I suppose I could build the kernel on the Raspberry Pi 4. Yeah, could do that. I think it's all set up to be a build machine. Is it? Oh yeah. There we go. Cool. Coolio. Yeah, because it's got. Yeah, that should do. Then I can just reinstall it tomorrow. Awesome. Cool. So we'll get the new kernel then. That'll be good because that'll be done by tomorrow morning. Then I can just reinstall this Raspberry Pi or test the kernel again. And yeah, it should be good. Assuming that the system integration test passes and I don't need to recompile any new packages. All right. Well, that'd be good. That's going to be good if that makes even a small improvement to the video situation. It definitely does here. It definitely does. It's not.
Yeah.
I still wouldn't. I mean, let me see. If I start doing some web browsing, let's have a look at the news. Let's type another on keyboard there.
Yeah, I unplugged all my extra keyboards and stuff and cleared my desk so that I wouldn't be getting confused where I'm typing while we're on this video.
Okay.
It's like.
just looking at a news website, which is quite heavy on images and layout. And it's, yeah, this is definitely improved, Brent. This is much better. It's not as good as the Rock Pro 64 or the Pinebook Pro, speed-wise, at the moment, but this is a big improvement from where it was only this morning. So that's...
Looks like, I mean, I don't have the working Video Core 4, and I'm watching videos at 720p high def, just using frame buffer with
Okay.
that set. Yeah. Just
Cool.
watching a podcast. You know, it's all muted, but just to see how it works.
All right. Well, I was going to push out the new kernel that I'd already compiled, but now actually it doesn't make sense. Yeah, it's going to go out with all of these changes in it, because that'll be quite a step forward, I think. And then if there's any other patches that we can add for the VC4 support, we can see if the community can find those, and I can add them in quite quickly.
You got something done.
Indeed. All right, Brent. Have a good one. Good to talk to you.
Yep. See you later.
See you later.